Okay, I think with that, we can move on to our next segment, which is the fireside chat. I would like to invite all the presenters back on camera, please. And Rob will help us facilitate the fireside chat. Rob?
Cool. Thank you very much, and really appreciate the awesome presentations here. Can everybody hear me good, I hope?
Yeah, for sure.
Excellent, excellent. As I went through these different presentations, took down some notes, and we've got some questions here just to start the conversation. But I guess Wolfgang, let me start with you. And we've got about 30 minutes here, so we'll use as much of the time as we can and see what we can get through. First question I have for you is software-defined vehicles like have millions of lines of code deployed by OEMs and tier one suppliers. How do you see cloud playing a role in streamlining the development of all this code?
Yeah, great question. Bringing it all together. I think this is the role of the cloud and the cloud platforms that we see growing and growing here. Cloud provides a very flexible, worldwide available instance that can connect services from different contributors and vendors into one pipeline. So it really is kind of the go for me at least the go-to technology to get all these different participants in the value chain together in order to streamline the software development and ultimately keep it safe, have all the testing and all that stuff done that is required to go into a car, right? So it's a place where it all comes together. That's maybe the short answer.
What kind of tools are you using? What kind of software development tools or cloud-based development tools are you using to build the code or manage the code?
So today as a lot of software in the automotive industry is actually generated out of generators. So we have our own tooling that is called EB Trezor Studio or Corvus Studio. That is essentially code generators for different modules that are used in a car. The question is, are you basically building that software stack, or are you building the software that's then later run in the car? And typically what's run in the car is a lot of it is auto-generated from from model-based designs, right? So that's the tools we use, and we are in the journey at the moment to bring these tools into the cloud. These are also tools that grown over the years. So talking about monoliths, I can also talk about monoliths here on the automotive end, right? So it's the same thing. So we need to separate it down into independent services and make it more cloud friendly from a workflow perspective. So that's the journey for our tools that we use. But again, the industry, the automotive industry is big and very diverse. So there's a bunch of tools that are out there that we use, as well as Elektrobit, to help us building our code. And it starts with open source stuff that we are all kind of used to right now, till paid tools for specific safety checks and frameworks like that. So it's not an easy question. It's basically all of it, right? So different licenses, different deployment methods, different technologies that we use at Elektrobit to build our products, but also that we use with our customers to build their products and ultimately the stuff that goes into the car.
Cool, thank you. I mean, as I've talked to manufacturing and automotive customers globally, it seems to be one of the biggest issues, just the tooling around development. So thanks for the insight there. Let me move to Tomas. next, and I will come back, I think, Wolfgang, to you. I've got one or two more questions for you, but let me just pull the panel here a little bit. What I found really interesting about your presentation, Tomas, was just the amount of data we're talking about that connected vehicles tend to generate. And I've worked with some customers who, they quote, billions of transactions or, across millions of vehicles. How do you manage that? As that data is coming in, how do organizations just handle that massive amount of data coming off the connected vehicle?
Yeah, good question. But as in any industry, I mean, you need a well-defined data management strategy to begin with, that details the data governance, how to ensure that the data is secure, that you have data privacy, and of course also the data quality you need, because all that, as you say, it's a massive amount of data, but it's not always the best quality of data that you get off the vehicles. So you have to manage that somehow and clean it up. And that's basically the data management strategy in order to make the data usable to start with. Then of course, when you have it, you need to create your data lakes. And it's not just one, at least not in our case. It's a few different ones depending on the case. And of course, then you store the data in the cloud-based data lakes. You can use the massive scale of the cloud, and you have the data close to the compute resources in the cloud. And then you can use also some higher level services for analytics and machine learning available in AWS, for example. So that's useful. But then I think the most important thing is actually to not always send the data. You do the processing on the edge. So in many cases, it makes the most sense to process the data at the vehicle edge in this case. So you can save cost for both data transfer, for cloud processing, and also save some latency, and even cater for some of the data privacy regulation things going on in the world. So when doing the processing, analytics, and machine learning inferencing on the edge instead, then you can send the result to the cloud, which is typically a far less amount of data and less frequent as well. And of course, utilizing the software-defined vehicle Wolfgang talked about, that's how you actually implement that edge processing in a good way. So those are the three top things to think about.
Thank you. Like, and likewise, I've talked to a number of customers who have to manage this data, and the regulation piece you bring up is really interesting, and I've heard that in multiple geographies, about anonymizing data and ensuring that we're meeting local regulations. I may come back to you here on another question, but let me just one more follow-up question on this, and that is, how do you build policy around this, and what are some of the frameworks that you do to try and build like a data strategy to handle this massive data? Because you just mentioned we've got regulation, we're trying to clean up data at the edge. You want to use this across organization for analytics. Like, what are some of the components when you help build a whole overall enterprise data strategy? What are some of the things you think about around that data strategy?
Good question. So how to answer that? We work a lot with the different regulation. I mean, in China, for example, you're not allowed to have the data leave the country, even if it's personal data. So in that case, we work a lot with the our local teams, and we ensure that we create the data catalogs that describe all the data and classify the data depending on if it's personal or sensitive or prohibited to transfer and those kind of things. So I would say data catalogs is the best tool to use.
Awesome. Thank you. Jan, really cool presentation, around smart manufacturing and transforming the manufacturing process. What are some of the easy ways that organizations what are some of the easy wins that we can target while transforming the manufacturing process? How do we set up some of these easy wins for success as we start moving towards smart manufacturing? What are some of those first applications or easy wins that you look for?
Yeah. So for what I expect or saw during the last years, and what is often a topic when we discussing with our customers, is that they try to strive for 100% solution over the whole manufacturing cycle or manufacturing line. And from my perspective, and I think we heard it a couple of times today already, you should not try to build everything at once, and whether it's to test and validate and go step by step. And as I already also showed it, we started with a standardized product, which is quite easy to implement because it's nearly the same every time, and you can easily set up a proof of concept and validate what you would like to do with that, and then go step by step forward. And also to try to get insights which you already have within your plant or with your manufacturing line. So all the maintenance people which are working there, try to transform their knowledge into some basic rules and automate them, that they are free for making more progress and even better maintenance or operations of their equipment. So the easy win is, or what I would suggest every customer is to not strive for 100%. Start with something small and then build it step by step, but always have in mind what's your vision, where you want to go. But yeah, do it step by step.
And then how do customers that are implementing smart manufacturing handle like the many types and variants of make and models and machines on the shop floor? Like the plants that I've been on, it's just a variety of machines. And so how do you handle that variance, and how do you create some either standardization around it, or how do you handle this?
What we are doing as Bosch is that we are investing a lot in digital twins, so that we digitalize all of our available information, that we link them, that they are available through different systems, so that you can access all this information through one single point of access. And the back end and all the information below, so where the information is coming from, which plan, which document store, whatever, is then easily accessible if you have such kind of a digital twin, or however you call your system of building it.
Cool, thank you. And then, Omar, you may have actually already answered this question, but it struck me as you're going through like I think your second to last chart in your presentation. But how did you overcome some of the challenges of siloed data in these manufacturing systems? Oops, Omar, you might still be on mute.
Can you hear me now?
Yeah.
Cool. Yeah, so I think the main element that comes here is really letting the vision drive us. And the vision was all about the human-centric design and obsessing with the experience of our main persona, who's the operator. And what we really wanted to do is we needed an enabling technology, and we needed an enabling architecture maturity to let that experience take the lead in our decisions. So this is the vision, this is where we wanted to go, this is the North Star, but a key element of it is to really have the architecture maturity in how we build and how we think about designing and building applications. And that's where the packaged business capabilities come in. And that's where the configurability element of these packaged business capabilities come in. So we're able to deploy the same capability globally to all of our factories and really challenge the status quo of, hey, you don't actually have that much customization requirements. We minimize the need for customization. That is what our plants, because everybody feels that they are unique, and everybody feels that they have a unique requirement. So we work very closely. A key element of this is our cross-functional mission-based teams. We work very closely with our process excellence counterparts, with our productivity teams, etc., to really make that process and align on what that standard needs to be, so to enable us to build and deploy these kind of capabilities. And then from there, really start investing in that ingestion technologies that I talked about with the industrial data fabric, ability to standardize the data formats. Because really, when the business started seeing the benefit and out of when you have a standard data format that's harmonized, how quickly I can just build and consume the same set of data that is contextualized and harmonized by many different applications for many different use cases, whether it's for engineering, whether it's for quality, whether it's for operations, whether it's for site services, regardless of what team needs it. This just made everybody, it took a few years to get there, right? This is hard work, and it wasn't an overnight transformation. But as we got through the standardization and implementing that centralized data repository, we had more control over the quality of the data, the accuracy of the data, and that became the single source of truth for all of the different applications that are going to consume this data. And the fact that we built that mission-based team, we drove a data-driven culture where you're really moving away from process data, like I said earlier, to data-driven processes. As I mentioned in the vision, our operators need to focus on identifying abnormalities, and our process engineers and product engineers need to focus on identifying abnormalities and not obsess about data that's coming from processes. So that's where kind of having this focus is, and aligning all the different functions on it. It really comes down to just having this mission-based team that's fully aligned on the vision, whether you're from the digital transformation team or whether you're from the business team. This is really what it came down to, is alignment across teams.
Awesome. And then just following up on that, you talk about data products, right? And building, and focusing on data. How do organizations enable agile development? How do you take the agile development methodology and now apply it to data products?
Yeah, I think it's just kind of following up on that. At its core, I honestly believe that you would only be effective and scale effectively by having the architecture design patterns of loosely coupled microservices. This is step number one. Step number two is starting backwards from identifying, validating, and prioritizing the business problems and opportunities is key. Because first of all, you're not going to be able to just go and do everything you want to do. So kind of understanding before we do anything, before we even develop any of those business capabilities, we really spend a lot of time on the problem identification and the opportunity. And when we build these products, we really address 4 key risks. And this is kind of the foundation of how we operate. First thing we do is we form the cross-functional teams. Second thing we do from a risk perspective, we ensure that the product we're building is valuable. Is it driving value for our end users? Would they go and buy it if they were to go and actually spend money on it, if it was an off-the-shelf product? Is it usable for the purpose of the problem and opportunity that we've identified? Does it solve the core of the problem? So that's where we do a lot of user research and usability studies with our teams, with our end users, who are consumers of these data products. Feasibility, is it feasible? And that's really when the whole industrial data fabric discussion comes in, is how feasible is it for us to ingest this data from the machines in the different plants? And there's a lot of different teams that are involved. We have network segmentation, we have network infrastructure, we have many different elements that come in. So how feasible is this technically and financially. And lastly is how viable is the solution. Viability comes from, we look at our end users separate to how we look at our stakeholders. Our end users, we focus on value and usability. Are we delivering the value? Are we solving their problem? And are we delivering a usable solution? And for our stakeholders, we focus on, let's say we have finance, we have legal, we have HR. Is the solution addressing the concerns and pain points of these teams as well? So this is where really the kind of the 4 key risks that we always start off any discussion about any data product or any product for that matter. And lastly, I would say is the cross-functional teams is key because we all together challenge the status quo. So it's a muscle where we challenge how we've been operating. Again, GE is not a digitally native company and it's a 100-plus-year-old company. So challenging the status quo is difficult, but it's essential for us to continue to evolve as an organization. And this is where leaning out our processes comes before building these digital transformation initiatives or these digital solutions. And challenging why you want to see certain data and why you want a certain data to what are you going to do with it. And the last thing is we need to monitor and measure the product performance. Obviously, with that continuous improvement, how effective is the data product in terms of meeting its objective, identifying areas of improvement, and how we do things differently moving forward. We have no problem of saying that this is not the right solution, and we just to kill a solution that's not working. I think having that mindset is also very important to be agile and develop faster and not dwell on some cost.
That's awesome. Thank you. I love your response around just, challenging the norms or challenging the status quo. I think it's one of the things that really drives some of the transformation I've seen across the industry. I've got one more question here. And if there are other questions from the audience, please type them into the chat. We'll be happy to
Rob, looks like
to ask them here.
we do have one question from the chat from Chakri.
Oh, cool.
In the scope of connected vehicles, as data security is a major concern, how is it ensured to have zero tolerance towards that?
So I guess I can take a stab at that. Talking about connected vehicles, yeah, of course, it's the number one priority to have security in place for everything, of course. But for us, for the connected vehicles and the data they produce, and also the access to the vehicles is really important to secure. It's a matter of as I said, keeping it number one priority. That's the first thing you do. The famous quote from AWS is security is job zero, right? So that's how we see it as well. But then how to actually do that? It's about having a really active cybersecurity governance function within both the OEM and in our case as a supplier. We ensure that we follow the appropriate security standards, such as the NIST framework for the deliveries we make, but also ensuring we follow things like ISO 27001 and also the new UN regulations 155. For cybersecurity of road vehicles, so that there's a lot of standards in place that you can ensure that you follow. And then, as mentioned, it's job zero. As soon as there is a risk or an incident related to security, that's what you work on.
Cool. Other questions from the audience? And Thomas, I guess while you're on camera, I've got one more question for you, a little different topic here, but you talked a little about, building different solutions and what goes into building and buying, making building and buying decisions. What factors go into making that build versus buy decision for a connected vehicle? Like, how do you decide what you're going to, buy off the shelf and what are you going to build yourself?
Yeah, for a vehicle or automotive OEMs, this question is of course an important one, and there are many different factors. I can bring up a few. First of all, I mean, what do you have as an automaker? Do you have an organization that can build it? That's the first question, I guess. If you don't, then you have to buy it, unless you want to build up the organization first. But assuming you do have some software development capabilities and also operations capabilities, then I would say time to market. What is the time to market requirements in first of all in the markets where you're not present as an OEM? I mean, that's one question, and then time to market when it comes to launching new connected car services in markets where you already are present, because it's quite easy to look into the big, more mature markets like Europe or North America, but lots of OEMs, they want to launch their services also in the so-called emerging markets that doesn't have connected vehicles yet, and it's hard for the OEMs to go there. So in that case, it could be a good selection to buy the solution. Another important thing is what I talked about in the presentation. Actually, that's commodity versus differentiating services. What is the strategy of the OEM digital platforms, and how do they differentiate an OEM from its competitors? What are the commodities that they can buy that does not set them apart from competitors in the OEM space? I mean, it's not cost effective for an OEM to rely on their own organization if the organization is not creating services that set the company apart from its competitors. Then you can buy it instead. And lastly, coming back to regulation, compliance, and cybersecurity. I mean, each region has different levels of engagement that range from a market-driven approach to government oversight or even to nationalism in some cases. For example, the United States has largely let the connected vehicle market play out with few limitations, while the European Union is setting strict laws to be followed, like the eCall regulation. Meanwhile, in China, they're demanding a strict policy for personal data and mapping data. So there's a very broad spectrum of compliance across these regions. And then, not to mention all the risks of cyber attacks in the industry, which makes cybersecurity more and more critical. So then, as an OEM, do you have the organization to manage all these complexity across the world? That's the question you have to ask if you want to build it yourself.
Cool, thank you. And I think we've got about 2 or 3 minutes left, and the last question I had here, really maybe in a minute or two, and Wolfgang, just come back to you, and you open a session. I'm going to close with you. Based on the framework you built out and the platform, the systems you built out, what kind of advances or what kind of metrics do you see as far as moving those use cases forward? With respect to test speed, gains in terms of test speed have you seen?
Yeah, great question, and as I said before, the automotive industry is very fragmented, right? So it always depends on the use case and so on. So this is a great chance and a great fit for the platform that we build and cloud in general to adapt to the different use cases and applications in a scalable manner, right? So there is improvements that are just 1x, so no improvement at all, but it's always available. So there's improvements in way different areas that were just not available and that you cannot measure in a time or cost kind of thing. In cost in the end, of course, but in a time advance. And then there is use cases where we run 70,000 test cases overnight that we were not even able to run overnight before in our on-prem solution, and we can run that now in a seamless manner, and that gives us then a real time advantage. And again, it's all about faster and accelerating time to market. So bottom line, it's not a one size fits all, but the cloud and the platform gives the scalability to adopt for these different use cases, and then they have their advantages built within. So yeah, it's a great improvement moving to that as a technology base.
Cool. All right, I think we're at time here. I want to thank all the presenters and for all their awesome presentations in a fireside chat.